So what does semi-annually mean? Right, so twice a year, very good. Quarterly and monthly, 12. Because I have 3 different options here, I'm going to create a function. So this is P1 plus R over N raised to NT. I'm going to write it again with numbers this time. 10,000, 1 plus 0.055 over N. And N times T is 5 years, so it's 5N. The reason I'm doing this is because I want to create this function, put in the graphing calculator. I don't have N in the calculator, so I'm going to plug in X. And then I'm going to replace X by 2, and then 4, and then 12, and get all the answers at once. Or you just repeat the operation 3 times. So 10,000, in parentheses, 1 plus 0.055 divided by X. Let me know if you cannot see. N power, in parentheses, 5x, and close the parenthesis. Now with second and table, I would plug in the 2, and then the 4, and then the 12. And then I will go and override it, highlight it I should say, to determine the decimal part. So for the first one, for n equals 2, I got 13116.51. So A equals 13,116.5. Oops, I went to the next page. 51. A equals 13140.67. And the last one, 13157.04. Now, the last one, which is continuously, I don't need to do that because there is only one calculation, which is 10,000 E2 RT 0.055 multiplied by 5 years. So get out of there and just put in 10,000 and in parentheses, no, I'm sorry, I don't need parentheses, multiply by E. Remember, I'm expecting a power, so parentheses for the power, 0.055 times 5, and close the parentheses and press enter. And the answer is 13,165.31. Any questions? Any questions? So in this particular case, if we look at all these numbers, we realize that in this situation, with 5.5% for 5 years, this is the best option. You can say it's not a big deal, it's not a big difference, but if we put more money in, it will eventually be more of a difference. So this is the best option for this situation. Any questions? Any questions? Is there any particular type of problem that you would like to go back and continue, or we move on?
I'm good with moving on.
Okay, any more problems from this section, or we move on to the next one?
Next one.
No? Very good. Okay, the next section, let me put this book away. Oops. I think I hit my stuff here. Is it still centered or not?
Yeah, it's still centered.
Okay, I managed to hit something by removing the book. Sorry. Okay. section 4.2, logarithmic functions. Okay, well, we don't know what the log function looks like, but a few minutes ago we did graph it. Right? We didn't have any idea what it was, but we already graphed it. Here's the graph of the log function when the base is greater than 1 and when the base is less than 1. Okay. So, the log function is the inverse of exponential function. We know that the exponential function, with regardless of the base, we say it's defined on all real numbers. This is a domain. And we say it takes values, or this is the range, 0 to infinity. The log function must have these two reversed, because it's the inverse function. 0 to infinity, which is a domain, and the range, negative infinity to infinity. The most important concept in this chapter. First, I would like to write it in plain English. Very, very important concept. It's the basic of everything we're going to look at moving forward. It's the foundation. Okay, so what is this concept that I'm talking about? What does it say? Any log equation, and you can say, you haven't even showed us a log equation. What are you talking about? I will in detail. Any log equation can be changed, replaced by, transformed into, whatever you want to say, transformed. Into an exponential equation, and vice versa. Any exponential equation can be changed into a log. This is the most important concept in the entire chapter. That's what I think. Well, how do I write this mathematically? Because this is interesting and important, but okay, how do I write this mathematically? So one more time. Any log equation can be transformed, replaced by, changed into an exponential equation, and any exponential equation can be changed into a log. I will be able to solve everything if I understand how to get from one to the other. Then there are no secrets for us at all in this chapter. But I need to understand how to change from this into this and how to change from this into that. And then no more secrets. Okay. So I'm going to start with a log equation. But first, notation. Notation for the log function, is something that looks fancy. Log base A of x. So how do we read this? Log base A of x. It's kind of a fancy notation. Log base A of x. Also, we do have two special log functions. Because we had two special exponential functions. We had a special exponential function with base 10, So its inverse will be log with no base. I'll write it in a minute. And we also had a special exponential function, e to the x, and it will have this notation as the inverse, or log function. So then, one is called common, like before, and the other one is called natural, exactly like before. So what's the difference in the notation? Log x. What does this mean? I don't see a base. When we do not see a base, we automatically know it's 10. But we don't write it. By convention, we don't write it as you see, it's log. The other one, it's still log, but instead of that for natural, ln. Again, no base. Well, the base is e. But we don't write it. That's the reason why these two functions are paired together. 10 to the x and log paired together on the same key, and e to the x and ln, natural log. It comes from German, it should be natural log, but it's log natural, so because it's coming from German. So e to the x, natural log. So keep in mind that you should always see a phantom 10 and a phantom e. Okay, so now we're coming back to convert this into mathematical terms. Okay. Any log equation, log base a of x is a number y. This is a log equation. On one side I have a log, on the other side I have a number. The simplest possible log equation. Log equation, a log, an expression with log and a variable x, and some number on the other side, can be transformed double equivalency. What does this mean? The log equation can be changed into an exponential. Any exponential can be changed back into a log. Both ways, this way and this way. And now, please pay attention. Let me put these in order. I have 8. Yes, 8 and 9. Okay, perfect. So now please pay attention how we convert this. Always start with the base. The base raised to this number equals this number. From the base counterclockwise. A raised to y equals x. A raised to y, not multiplied, but raised to, equals x. Understanding this relationship between these two will open all the doors of in this chapter. We'll have no difficulties in this chapter. So, based on this, I would like to show you why the log function is the inverse of the exponential. I just put this in writing. The log function is the inverse of the exponential, but I haven't showed you why. I established that the exponential, as before, has domain and range, and then the log has to have them reversed. I established that this is not a friendly function. It has a vertical asymptote at 0, and it's defined only for positive numbers. But I have not shown you why log is the inverse of the exponential. Now I'm ready. Knowing this concept, we can explain. So now, I would like you to look at these bubbles, and I would like you to give me an exponential function. Let's start with the basic exponential function. No transformations, just the basic exponential function. You choose the one you like. It can have base greater than 1, it can have base less than 1, any exponential function you would like to look at. And then we're going to use some x values, let's say 0, let's say -2, and let's say 3. But we have to choose the exponential function first. Can anyone choose an exponential function? Any? Okay, I'm going to use 10 to the x. And the name of this is common exponential function. Okay, so I need the corresponding y values. When x is 0, how much is y? Very good. When x is negative 2, I have 10 to negative 2, which is 1 over 10 squared, which is 1 over 100. And when I plug in 3, I have 1,000. What do you think the base of the log function will be as the inverse? When we graph the exponential, yes, so it has to be identical. So remember, I reversed these points. Reversing these points here, I have to have the same base. So when I reverse these points to get this function, I have to have the same base. So then, this is log base 10, which we don't write, you know, it's a phantom in there, x. And now I have to show you that when we apply log to 1, what will the answer be?
Yeah.
Very good. When I apply log base 10, common log, to 1 over 100, I have to show you that the answer is?
Negative 2.
Correct. And when I apply log to this number, I have to show you that the answer is, because otherwise you should never believe that this is the inverse function of that. So, we're going to start by applying log to 1. So log of 1 is a number. I have no idea what this is, but I know the equivalency. Which base is this? I don't see a base again. So what is it?
10.
The base is 10, right? The base is 10. It has to be the same base.
Yes.
Good. So 10 raised to y equals 1. 10 raised to y equals 1. And now let's think. 10 raised to which power will be 1? There's only one number that I raised. Say it again.
0.
That's it. So indeed, I connected back 1 back to 0. Now I have to apply log to this number. Log 1 over 100 equals y. I have no clue what this is, but I know. Can anyone tell us how to convert this into a log, from a log equation to an exponential equation?
And 2y equals 100.
So obviously this can be changed into 10 to negative 2 because it's easier now to identify what y equals to. There is only one number we raise 10 to get 10 to negative 2. What could that be?
Two.
10 to negative 2 equals 10 to negative 2. Very good. So when we apply log to 1 over 100, we recover negative 2. Finally, there is no need, but let's do the last one as well. So we have log of 1,000. I have no idea what this equals to, but I can change it into an exponential equation. How do I change it into an exponential equation? I start with the base and I go counterclockwise. 10 to y equals 1,000. But 10 to y equals 10 to the third. So what is the only option possible for y?
Just one.
There is nothing else. So now we do know that 10 to the x and common log x are inverses of each other.